So now we'll learn about securing the virtual networks. So as you can see that there are three underlying networks of infrastructure as a service network, storage network, and management network. Service network is the one that connects the compute nodes to internet and instances to instances. This is the API layer. And next is the storage network, because there's a lot of traffic. There's a lot of volumes going from storage to storage. It is on that layer. Compute nodes to instances, storage to storage. So it requires a network in itself. And then there is a management plane network that you really want to isolate these three for security reason and for performance reasons, because storage, a lot of volumes go from one to another. Service layer should be really performing well for the connectivity of API. And of course, management layer is the core that connects all of it. So you want to secure and isolate that well. Then comes the building the networks for this cloud. And this will be if you were building your own network. For example, if you were a service provider and then you were making your own cloud, you're building the cloud for giving as offering as a provider, then this is not so much applicable for the consumers, because consumers really do not deal with the physical networks, etc. So when you are building the underlying networks for the cloud, you want to really have separate physical networks. We used to rely a lot on VLANs, but not anymore. Some of the clouds are still based on VLANs, but that's a good question to ask. What kind of SDN you have. So these days, SDN, software defined network, is the key. And there are many other things that SDN, what version, what type of SDN, what it depends on which version and physical infrastructure, etc. And then you want to isolate the cloud networks from the LAN. So cloud network should not be part of the LAN itself. It should be a separate software defined network. There should be, you really want to isolate that. There should be only two outside connections. The one to the network manager to route the internet traffic, which for the API calls. And the second is the management and the network manager itself. So the one is the API server and the management, and the other is the network manager. You just want two layers, two very specific restricted connections to the outside world. Then let's talk about the virtual networks. Everything in the cloud is virtual. Virtualization is a key for having the cloud. That's the core of the cloud. So virtual networks, you would have the same security as physical network, not much difference there, but it always runs on the physical. So you want to secure the physical network as well as virtual network. And it may the virtual network, you can simplify a simpler stack to build a private cloud if you are building a private cloud. Though in the private cloud, it is all your responsibility, the physical network, the virtual network, etc. So this is creating the virtual networks. And then let's look at the VLANs. There's some emphasis on what types of the networks are there. VLANs are, they used to be used in the cloud, not anymore. Um, these are the existing technology which is mostly primarily used for the on-prem network or private network. um, it is designed, it is good but not good anymore for the cloud. The software defined network is the key that really decouples the network control plane from the hardware. It really isolates that. It provides an abstraction layer which VLANs do not provide. VLANs provide the abstraction, but they really don't not provide the isolation. Um, and there are multiple, implementation, different types of software defined network. You may want to ask the provider what kind of software defined network they have, and this can really create an isolation between the networks. Um, let's look a little more about the software defined networking. It really decouples, as I said before, it really decouples the control planes, from uh, control plane from the compute plane. So it's very easily to secure. Open flow is one of the example of SDN. Remote access is controlled by the administrator, so not everybody can remote into the SDN. And some of the other key things are that this is API enabled. So really it's a very granular control there. Who can do what and who can access what. You log into the SDN and someone else logs into the SDN. Their view will maybe what they can access and what can they do is totally different from the other person. Because it provides that isolation because it relies heavily on the packet encapsulation. Um, what are some of the benefits of the secure SDN? It's, again, I said before, it's very easy to isolate. Very easily it provides the isolation between the management plane and the compute hardware. The firewall, the topology is not limited to the physical structure. You can have the same set of IP addresses in two SDNs, and they may have exactly identical IP addresses, same IP addresses range on the same physical network, and perfectly work fine with no issues. So that is a really, really benefit, a good advantage of having an SDN. And last but not least is the security group. The SDN firewalls, they are default deny. When they are orchestrated, they are default deny, and they are orchestrated through the APIs, and they provide the granularity of the host firewall, which is very difficult to manage because they will be on each host, while the network appliances are kind of ubiquitous. You just configure them one and they are available from everywhere. That's what the advantage of security group. You create a security group and then you apply this security group or associate this security group to any of the hosts, and that becomes a host like a host firewall. So it's very easy to manage. That policy can be applied to all of those hosts once created. So it really provides the granularity of the host firewall with the network appliance, kind of network appliances. So and then it provides the context based configuration and the tags. So you can tag some of the security use. For example, you can tag this as security group for databases, and then you know, it can be applied to multiple databases all at once. Um, and then some more. It's policy based, context, tag, and it's policy based, not necessarily tied to an IP address. You can have it on IP base, but no, it's not necessarily tied to the IP address. You can include the context tagging, we talked about that before, and no additional hardware or software is required. It's part of the network. And so when you just click of the button, your provision is as part of the network. That's the offering of the cloud, that you don't have to have any separate software hardware. You just configure it. And Then you can apply it on a per asset level, per instance, per PaaS object, but it is managed outside. So if your machine was, your EC2 instance was compromised, they can't do anything. They cannot change. The hacker cannot change the security group, because security group is at the management plane and they don't have access to it. So it really provide, and it drops anything which is, it's integrated into the SDN logic. So if you say that allow the traffic from port 80, it will just allow that, and it will drop everything else. So no matter what request comes, it will just look at that, what port, what context, what tag, and then it will not allow any other traffic. So it is very easy to manage, and provides a very granular security, which is the SDN firewall called security groups. Then how do we control the blast radius? So you can have, in one account, you can have multiple VPCs, one for development, one for test, one for production. So that provides a very nice isolation, as opposed to, mixed things. So segmentation, isolation, is, just by creating different private networks or private virtual private networks there, VPC, virtual private clouds, and but you can go a one level above, by having a separate account. So you can have a totally separate account for development, one for test, and one for production. That's even beyond having 3 separate VPCs. And it doesn't cost you more to have separate accounts. Charges, the cost or charges from the account are per use, what resources you use. So if you can have separate account, that's the real isolation. So that's the recommended, that you create different accounts. And these are some of the differences between, if you have to sniff the traffic for security, on a traditional LAN environment, you would put the sniffer between the 2 servers on the physical network. But in the virtual environment, in the cloud environment, the VMs to VM communication may be, on the same host, on the same server. There is no point that this traffic will go out on the physical network. So it's very difficult to sniff that for security reasons. So what you would do, there are some of the options. You can, you can have some physical, in traditional environment, you could have a physical appliance, and you could just use that, route the traffic through this physical appliance. But that's not possible in the cloud. You cannot have a physical appliance in the cloud. So you can have a virtual appliance, which will and route the traffic. That becomes the bottleneck then, because then you are routing, you are kind of, it becomes a choke point or bottleneck because you are sending all the traffic there to sniff. So you have, then it has to support our auto scaling and whatnot, configuration, etc. um, the other option would be to have a host software which is sniffing, which is always listening. um, and that's, a lot of providers, security, third party products come with the host software now. And that will be added to each instance, each virtual machines, etc. But it becomes very cumbersome to manage. You can bake it in the image, etc. But the first recommendation would be to use what cloud provider provides natively. So lot of cloud providers provide you those logs, for example, VPC flow, etc. And that will be the first choice. If that is not available, then you will pick either virtual appliance or the host software. That's the recommendation. Then in the multi-cloud environment or multi-account environment, there's a concept of the bastion host or the transit VPC. So how would you connect from data center? And as we are recommending the isolation and having separate accounts, so you can have, your clients can have hundreds of accounts or thousands of accounts. So how would you connect from your data center to those cloud accounts? Is you will create a bastion host, which will become you will have a VPN, dedicated network or VPN between data center and this bastion host. And this bastion host may have further VPN direct connectivity, or it can have a cross account access, peer-to-peer account, peer networking, etc. That's how you would connect easily to multiple accounts or multiple cloud providers. Then there is a software defined perimeter. This is an open project with CSA. This software defined perimeter takes care of it dynamically provisions the certificate and creates the connectivity, a session, dynamic connection. So it does the authentication, authorization for devices, users, and then the connections are initiated on the fly, dynamically, and even the certificates are provisioned and through the gateway from the DMZ or data center to the gateway, and then there is a connectivity outside. So that is there is a controller there, software defined perimeter controller, that controls who can access, and authorization and authentication is taken care by this controller. And here is a little list of what is the provider and what is the consumer's responsibility in a cloud environment. So provider has to secure the virtualization technology, the physical network, the physical compute, the management plane, and the VMs, the virtualization. And they have to expose all the security controls, for example, security groups, so that the cloud consumer can manage and configure those security groups for the security controls. And they have to, it's provider's responsibility to make sure that all the attack surface are taken care, they are controlled, they are disabled. For example, the packet sniffing, etc. And they have to secure the virtual management infrastructure as well, and they have to expose the controls, the restricted controls to the consumer via the API or through UI. And UI is also based on mostly APIs. The same functionalities offered by the provider through UI or APIs. On the consumer side, they have to create a proper network design, virtual network designs, so that is it the correct architecture, how accounts are isolated, how security groups will be connected, how security groups will be associated, what are the policies, etc. They have to manage the security groups and its configuration. They have to their part of the shared responsibility model. They have to secure their portion of the management plane and meta structure, proper IM roles, proper IM policies, resource policies, etc. So that's where it's a shared responsibility or joint responsibility. um, so some of the recommendation to sum up, it's a summary here. Prefer SDN wherever available, whenever available, as opposed to VLANs. SDN capabilities for multiple virtual networks and multiple accounts, to use multiple accounts to isolate them, segment them, separate accounts for virtual networks. And virtual networks, they really reduce the blast radius. If something gets compromised, not everything will be compromised, as opposed to traditional data center. Once you got the network, you got it. And of course, the security groups should be configured well, because these are default deny. It's that's how it's provided by the provider, but consumers' responsibility is to make sure that they are configured correctly. And the firewalls should be per workload basis as opposed to per network basis. You could create these firewalls. Once you create them, you can associate to each workload. So it's very easy to configure. It's kind of, it's like a network appliance, but gets attached to each host. And we should take advantage of that. And we should always restrict the traffics unless it's really needed. You would really restrict the traffic. For example, if your application server has to connect to the database, you will just open that particular port and that type of traffic, HTTP or UDP or FTP. You will the context based and the port based, and you would tag them well, and you'll really take advantage of the security groups. So that's kind of end of the securing network, and these were the recommendations. Thank you.